Welcome back. In this video, we're going to talk about the differences between strong and weak electrolytes in the context of acids and bases. We've used these terms before, but now we're going to look at exactly which acids and bases fall into each category, and what that looks like in a chemical equation. When we call an acid or a base strong, we're not talking about how corrosive it is. We're talking about its math. Strong acids and bases are strong electrolytes, meaning they dissociate completely when they hit water. In a chemical equation, we show this with a one-way arrow. This tells you that if we put sodium hydroxide in water, you won't find any NaOH molecules left. You'll only find separate Na plus and OH minus ions floating around. Most of the substances we work with in this class, like hydrochloric acid or sulfuric acid, are strong. Similarly, common bases such as sodium hydroxide and potassium hydroxide are also strong electrolytes. These are the heavy hitters that break apart completely, providing a high concentration of H plus or OH minus ions. Now, most acids in the world are actually weak acids. The big one to remember for this class is acetic acid, which makes up about 5% of vinegar. Notice that its formula starts with an H to show it's an acid, but when it dissolves, we use these funny double-headed arrows. This indicates that the reaction goes both ways, and that most of the solution actually stays as intact acetic acid molecules rather than breaking into ions. Finally, we have weak bases. The only weak base you need to memorize for this class is ammonia, NH3. It's a bit of a weirdo because it doesn't have an OH in its formula, but it reacts with water to produce a small amount of hydroxide. Just like vinegar, we use those double-headed arrows to show it's a weak electrolyte, meaning it's mostly NH3 molecules in that bottle of Windex with just a few ions floating around.